Okay, hi everyone. Now I want to make a video for how to make a best fit curve in Google Sheets. So I did Excel in the last video. Here's how you do it for Google Sheets. So again, I've copied and pasted my data into Google Sheets. I'm going to select the first two columns to start with, A and B, and I'm going to hit Insert, Chart, and then if it doesn't automatically come up as a scatter plot, I'd want to change that to be a scatter plot. But this one is a scatter plot. If you edit chart, it'll open up this thing over here, this tab, and now I can do a number of different things. One of the things I want to do is make sure it's a scatter chart, and then if I customize it, I can go to Series and I can add a trend line. Okay, maybe I'll add data labels if I want. I can also add a trend line, and rather than doing linear, well, let me first show you the equation. So if I say label it by the equation and then show r squared, then notice that it gives me the equation right here. It's saying y equals negative 119x plus 2220 would be my linear model for this data, and it would say that that'd be about an 0.85 r squared value. So that's like a pretty decent fit, but not the world's greatest. And then, so maybe I'll try polynomial, because if you notice, this data looks like it has some curvature to it, and it even looks like it's curving up for a little while and curving down, which suggests that I'd probably want to use at least a degree 3 polynomial. So when I change it to degree 2, I get this quadratic equation. It's got some curvature, it does fit the data okay, and it gives you a 0.909 for an r squared value. So watch what happens to the r squared value when I go to 3. When I go to degree 3, all of a sudden I'm all the way up to a 0.979. So that's like a 98% match with the data. So that's good enough for me. So what I would recommend you do now is, you can't, unfortunately, I don't know how to copy and paste this coming from Google Sheets, but you can just write that down and then type that function into Desmos, and you should get an equation that looks something like this. Notice that Google Sheets is rounding slightly different, so it'd be like negative 7.6 x cubed. It's slightly different than what I had when I did Excel, but it's not that different, right? Negative 7.6, it was there. It's just rounding to the 10th spot instead of hundreds. So I'm just gonna use what I got, the same graph that I got from Excel. You know, this was 101 in Excel, and I think it's 480 or 468 and 2412. Is that what Google Sheets had? Yeah, 2412. So you can see these are matching up really well, just rounding to different things. Okay, so you do that, and then you go back, and in Google Sheets, you would then want to make a second graph to get the other equation for monthly cost to own. So the idea here is you select A, and then you hold Control, and you select C, and that will select those two columns, and then you can again select Insert Chart, and then make sure it's a scatter chart or scatter plot, and go to Customize, and then you need to go to Series, and then you can add a trend line, show the r squared, maybe use the equation to label that trend line. And notice this is only a 0.71. That's a pretty bad r squared value, and that's because there's so much curvature here. So again, I think I'm going to want to use, instead of linear, let's first try polynomial. In degree 2 I get 0.89. If I increase to degree 3 I get 0.931. So that's like a 93% match, and I think that's good enough. If you go to degree 4, it's, you know, you're going up by from 931 to 0.934. That's only 3 1,000ths better. So I'm going to stick with this model here. So you copy and paste this function into Desmos, which again is essentially this function that I've copied and pasted from Excel. And then to calculate your optimal profit, what you would do is you would take profit as revenue minus cost. So R is the monthly revenue you can get from renting out an apartment. C is the cost to own that apartment, and then profit would be revenue minus cost. So you're looking for when is the red curve minus the blue curve the largest, and so Desmos plots that as this green curve, P equals R minus C, and it's saying that when X is 4.368, when x is 4.368, that's when the distance between the red curve and the blue curve is the largest. And so that's also where the derivative of this green curve is 0. And so you would get that this is your optimal profit is 327, and your optimal distance from downtown is 4.36, according to this model. Of course, this is slightly different than when I did in Excel, and that's because we had some rounding error when I used Google Sheets. But still, it's very close, and you can still see that anywhere in this region between like maybe 3 miles and 6 miles from downtown is going to be your optimal place to shop for a place, because you're going to be making anywhere from, let's say, $289 to about, I don't know, $278 a month. So while this is the absolute best point, these points in this region are also very, very good. They're going to give you about the same profit. And again, that's because the slope here is approximately 0. Okay, so hopefully that was helpful. If you have any other questions, please don't hesitate to ask the TAs, Victoria or Tim or myself. All right, have a good day. Bye.